Okay, so I asked you to do some questions using the work equation. First one's when we're on page 221, number 1. A weightlifter, Paul Anderson, used a circular platform attached to a harness to lift a class of 30 children and their teacher. Now, I think Paul Anderson's supposed to be some famous weightlifter that I've never heard of, but maybe you have. While the children and teacher sat on the platform, Paul lifted them. The total weight of the platform plus the people was 1.1 times 10 to the fourth newtons. So the FG is 1.1 times 10 to the fourth newtons. Now remember what we said in the last video. When you're lifting something, there's an FG acting down, and we're assuming then that if you're lifting it, you're putting a force equal and opposite to its weight to lift it up. So the FG is really the F in the work equation. When he lifts them a distance of 52 centimeters at a constant velocity, so that does indeed tell us then that F is equal to FG, and the delta D is 52 centimeters or 0.52 meters. How much work did he do? So he's putting a force upward and they're moving upward. So the angle here is going to be 0 degrees. W is equal to F delta D cos theta. So W equals 1.1 times 10 to the fourth newtons times 0.52 meters, and then cos of 0, which is 1. So W should equal 5,720 joules. Now it does go on and ask a second question, which says, how high would you have to lift one child which weighs 135 newtons in order to do the same amount of work? Okay, so in part B then, you're looking for how high. F delta D cos theta rearranged for delta D. So delta D is going to equal W over F cos theta. And it says to do the same amount of work. So the work done is the 5,720 joules. And this time the child that you're lifting is 135 newtons. And the angle will still be cos of 0. And when you do this, you get a delta D of 42.37 meters. I hope you have really long arms if you're going to lift something 42.37 meters. The library at the school is just over 9 meters tall. So it's like 4.5 times the height of the library. Probably not going to happen. Number 2. A 75 kilogram boulder rolls off a cliff and fell to the ground below. The force of gravity did 6 times 10 to the fourth joules of work on the boulder. How far did it fall? Okay, so again, W equals F delta D cos theta. So we have a boulder and it's going down. The FG is acting down and the boulder is moving down. So the angle again is going to be 0. And it tells us the boulder is 75 kilograms. So we can find the FG. It's just mg. Okay, so if we fill that in over here, and it said, how far did it fall? You're looking for delta D. So delta D is equal to W over F cos theta, or W over mg cos theta. So in the question they tell us that gravity did 6 times 10 to the fourth joules of work, 75 kilograms times 9.81 meters per second squared, and of course the cos of 0, which is 1. And you should get a delta D of 81.55 meters. Okay? Number 2. Number 3. A student in physics lab pushes a 0.1 kilogram cart on an air track over a distance of 10 centimeters, doing 0.0230 joules of work. Calculate the acceleration of the cart. So 0.0230 joules of work it says the mass of the cart is 0.01 kilograms, and it says that you've pushed it a distance of 0.01 meters, and in the end you're looking for A. In the beginning, with the W and the delta D, we can find F. W equals F delta D cos theta. So F will equal W over delta D cos theta. So 0.023 joules divided by 0.1 meters. And again, it's moving in the direction you're pushing it, so the theta is 0. And you should get a delta D of 0.23 newtons. That's not the final answer, though. The question wants to know what's A. And we know F net is equal to MA. It's an air track, so the only force will be the force you're putting on it, no friction, because an air track is like an air hockey table. It's floating on a cushion of air. So it'll be A is equal to F over M, so 0.23 newtons over 0.1 kilogram, and you should get an A of 2.3 meters per second squared. Number 4 is a couple of pages over on 225. And it says, as soon as I find the page, with the 3 times 10 to the 2, so a 300 Newton force, a mover pushes a heavy box down a hallway. Work done is 1.9 to the 3rd joules. Find the length of the hallway. So with a force of 300 newtons, and the worker does 1.9 times 10 to the 3 joules of work, and you're looking for delta D. So W equals F delta D cos theta. So delta D equals W over F cos theta. So 1,900 joules over 300 newtons times, again, the cos of 0, because he's pushing it in the same direction as it's moving. And you should get a delta D to be 6.33, and I think the 3 might be repeating. 3 meters. Okay? Number 5 says, a large piano is moved 12 meters across a room. Find the average horizontal force that must be exerted on the piano if the amount of work done by this force is 2.7 times 10 to the 3rd joules. So delta D is 12 meters, and W is 2.7 times 10 to the 3rd joules, rearranging this time for F. So it should be F is equal to W over delta D cos theta. So 2.7 times 10 to the 3rd joules over 12 meters, and again the angle will be 0. And F should end up equaling 225 newtons. Number 6 says, a crane lifts a 487 kilogram, and remember, if you're lifting, the force is going to be Fg, which is mg, so there's the m. 487 kilogram being vertically at a constant velocity. The crane does 5.2 times 10 to the 4th joules of work. So W is equal to 5.2 times 10 to the 4th joules, and it wants to know how far have you lifted it. So W equals F delta D cos theta. And this time we're looking for delta D, so it's equal to W over F cos theta. And remember, the F is going to be Fg, or mg. So 5.2 times 10 to the 4th joules divided by 487 kilograms times 9.81 meters per second squared, and again cos of 0. And you should get a delta D to be 10.88 meters. Okay. Number 7.